Hey everybody, Adam Savage here in the tested offices with tested family member Spot. Now we've been developers for Boston Dynamics Spot Robot for about the last year and change, but very recently a brand new ability was added to the Spot family, and it is an articulated arm. We sent our Spot back to Boston Dynamics, to the mothership, and they added the arm and sent him back to us. So today we are going to run Spot through its paces. We're gonna learn about the arm, what it can do, the interface that we have with it, and of course we're going to have some fun. But I want to point out that I'm working in proximity to an industrial robot, and that my comfort level is based upon the institutional knowledge of a year spent with this little guy. Our whole crew is cognizant of the dangers of working around him while his motors are powered. All right, that disclaimer out of the way, let's get to work. Ooh, continue, grasp, succeed. Yes. There we go. Hello. Ooh, here, go get it. Pick up object. I want to see this again. That's the object I want. Any orientation. Go get it, Spot. Go get it. Oh, it's so cool looking. All right, continue, grasp, succeed, operate arm. The roll of tape is perfect. Oh, look at you. Your arm is staying, wow. The arm is locked to the world. So there are different, the arm adds so much complexity that it's a little difficult to wrap one's head around all of the possibilities, but Boston Dynamics has done a pretty good job at localizing some of the tasks. But this one is the one of the things I find most amazing is I think they used to call this chicken head mode, where the head stays in the same position no matter what the body is doing. Yeah, I mean, that's just far out, man. So at this moment in time, Spot, while his body understands the shape and the space that he's in, the arm does not. Even though it's got a camera in it, right now, the way it's achieving this chicken head business is through effectively dead reckoning. It's using math to know where the arm was and then making all the calculations about the motor positions as the rest of its body is moving, which from a mathematical standpoint is mind-blowing. Yes, okay, go back. There we go. So the most basic control that we can have with the arm is just to operate the arm. And with this, you can use both joysticks. So left joystick up activates the base motor here and propels the arm forward. And notice that it attempts to keep the head in a kind of a reasonable linear orientation. If I left to right, tilts the head but allows the body to move with the head in order to maintain as much as it can. I find that really, really beautiful. That's left and right, left controller, up and down, left controller. I think if I push this button, I get right. I get hand pitch, right? Yep. I get yaw ham. Oh my God, whoa! Oh, okay, hold on. That is really beautiful. I forgot about this one. It's just absolutely gorgeous. I was learning this software on a ever so slightly different previous piece of software, and so now when you now there's a lot more information here. It's telling me that it's telling me what the various joystick controllers do, and it didn't do that yesterday when I was learning this, which is great. Okay, so grasp, release. Oh, look at that. Look at ground. Oh, look at he's looking at the ground. Also, I'm looking at Spot's camera here. Operate arm. There we go. That's me. Look, the thing you should realize is that when you are walking to the television with your dinner and you're carrying a glass of wine and you're holding onto a plate, and then between your fingers you've got a bottle of ketchup, and you're navigating the stairs, you are doing a set of actions that is mind-blowingly complex from a mechanical standpoint. The number of systems monitoring your balance and your verticality, et cetera, is gigantic. And the maneuverability of Spot's arm is all to give him the kind of range of motion we have with our bodies. But I'm also like, there's a way in which being able to move this arm around humanizes Spot for me, and I love it. I love having this extra library of kind of movements that he can do. Oh, we're just trying to get to know him. We're trying to help him walk out of the uncanny valley and not creep people out. And each time I like understand a little bit more of the functionality, he becomes a little bit more of a personality. Okay, I'm falling in love with Spot. Is that okay? Is that too much to say? The most basic type of grabbing, I mean, obviously I can open and close his jaw there, and I can activate his arm and do stuff, but that's still a long way from me being able to actually grab something. I mean, I will try. Here we go. Let's see here. I'm gonna try and pick up the no face over there. Ooh, 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 ooh. Okay. Let's see. Ooh. Oh, I just knocked the head off the Iron Giant. I think Spot is establishing dominance. You know, when my dog rests her head on any part of me, it's like, it feels like such a compliment. That's not what's happening here. I'm not gonna do my no face. We're gonna do this roll of tape. And I'm going to attempt to do this manually to show you how much easier it can be than the way I'm about to try it. All right, here we go. Up, over, open, oh, open. Okay, wait, how do I tilt that? Right. Hand sideways, there we go. No, pitch hand, there we go, wait. No, roll hand, there we go. Okay, so, moving forward. Moving forwards, taking all my breath. All right, here we go. Open, hand, move forward. Hey, yeah, now we're getting it. Okay. Oh, hey, oh! All right, here we go. All right. Go! Oh. Open, move forward. I am making a point here, I promise. Oh, come on, don't do that. This is the future, everybody. Come on. Finally. Oh! I think I personally need a break from picking stuff up, so I'm going to try opening the door. I'm really excited about this one. It blows me away that he can even think about opening a door. Let's see how well he does at the actual task. Okay. Open door. Here we go. All right, buddy. There's your door. Open door. Okay, touch door handle. Doink, there she is. It is a door that swings in swing, and the hinge side is on the right. handle type. Yeah, let's try this. Wait, yeah, so it's an in swing, right? Let's try this, open door. He's like assessing it with his, oh, 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 whoa! Come on, buddy, you can do it. Oh, he's trying again. This is amazing. Oh, you almost had it. Are you done? All right, let's try that again. Open door. There you go. There's your door handle. It is an in swing. It is, actually, let's say unknown. Let's have him figure it out. The hinge is on the right, and we go open door. All right, buddy, you could do it. He's looking at it, his cameras are like, this is a doorknob. There is so much programming going on right now in his assessment of his surroundings, his distance, his attitude. It's really cool. I mean, there's machine vision. Oh, there we go. Oh, wow! Holy, sorry, I don't mean to yell. That is amazing. That. In 1991, I was working for Chico McMurtry at Amorphic Robot Works, and we were making a robot called Ropey. And Ropey climbed using 6 actuators. 1, 2, 3, 4, and 5 and 6, right? So he could move his arms out, up, and he could grasp. And what he was doing was he would climb a rope, hold onto it with both hands, let go with the lower one, out, up, over, grab, pull, let go, up, over, grab. And the very first thing we did with him when we started him up was, I think I was controlling him. I accidentally activated one before the other had cleared it, and I went like this, and I broke his spine. I bent the whole thing, and he never grabbed a rope again. Just, if you had told me at that moment what was going to be possible watching Spot open that door, I would have been like, yeah, I doubt it. Well, this doubter is convinced. That was amazing. Well, Spot can open a door just beautifully. That was so beautiful to watch. But I still need some work on my ability to get him to pick stuff up. So I think I'm gonna head over to my cave and make a trash receptacle, which will sit right about here, and come back here and try a game of picking this place up a bit. Well, with Spot's newfound prehensility, is that a word? Yeah, sure, prehensility, you know what I mean. With his new arm, we think that what he could do is tidy up a bit. We think he could go around the space picking up some things, sort of like a more respectable Roomba. No, way beyond that. At any rate, we're thinking that Spot will go around tested picking up trash. And if he's gonna pick up trash, he needs a place to put it. And when I look at the topography of Spot, here is where it should go. Now, I'm thinking of a trapezoidal trash receptacle so that it's got a wide opening that gives him an easy drop zone. It needs to rise up off of about right here and clear both the back of the arm swing and the legs. So I think it's gonna come up and be just sort of like that. Let's get to building. Okay, so first and foremost, yeah, let's say it's that. It's 12 inches. And let's say that it's, what is that? About 6 inches deep. 12 inches opening, 6 inches deep, okay. Two more. This is why I love styrene construction, because it allows for very, wait till you see how fast I'm able to rapidly prototype this. Okay.
2, 3, 4. Those are identical. We will work out the hole size among them in a minute. And now we'll use that as a template to cut the others. One thing about using one piece as a template for other pieces, always use the same piece as a template. What I mean is, I cut out piece number A, and then I used it as a template for piece B. Then I used A as a template for piece C and D. If you use piece B as a template for C, well, you might have made an error in the A to B translation that now is going to compound in the B to C translation, and if you then continued to D, you see where this is going. Introduced errors like that can start really small in the just a few hundredths of an inch and then ruin your whole day. So always use the same piece as a template. Okay. Now we're getting to the gluing of the styrene, and I am going to do it, well, you'll see. It's just the thing I like about styrene is that it's a weld bond, which means this solvent that I'm using, it actually melts the styrene and causes the two halves to actually chemically join, mechanically join effectively, yeah. So it melts the polymer chains on each side of the equation, and as they dry, they reconnect and make one piece. That's what welding is. I don't mean to sound so authoritative. No one's ever taught me a lesson in welding, but you know what I mean. Look at that. Long enough for me to describe it, and it's holding up. This is, if you really want to see something remarkable, find yourself a day when you can watch model maker and my friend John Goodson, who made a bunch of the models for the Mandalorian seasons recently. Watch him do styrene construction. He's a master of the form. I think I'm gonna do the same thing again. Right, and then I'll join these two halves. This is similar to how they build big fish tanks out of acrylic. Those are also weld bonds. I mean, they soak the acrylic in those cases to kind of soften it up, get it ready, but all right. So I think how I'm gonna do this is this, right, blocks, there we go. 1, 2, 3 blocks are fabulous for styrene construction. Okay. Good. All right. Almost there. Yeah. Oh, okay. So clearly that needs to cut down a little bit. I want to be careful about moving this because it's barely being held together. I'm going to add some structure in a minute, but for right now, oh yeah, I way overdid this. Wait. Is this the one that's meant to be? That is. Okay, that's much more like it. Well, that's just gonna sit right there, and I'm gonna give it some glue all the way around its perimeter and let it soak it up and become really good friends. I'm gonna cut out some corners here and just reinforce some stuff. Okay, we're almost there with my garbage receptacle. It doesn't look like there's any holes. And this is what you could do with styrene construction in a very, very short period of time. Okay, let's go look at where this is gonna sit. So it's gonna sit like right about there, which means I need a couple of supports that go to that. And what is that? That is just about 6 inches. Is that 6 inches? Hold on. Yeah, that's 6 inches. Yep. So 6 inches up and over one full width of itself. 6 inches up and one full width of itself over. Okay. Oh, wait a second. Is that just under 12? It is almost exactly 12. So if that's almost 12, we're going to go just under 6 inches. Come on. There we go. 3, 4. Oh, I get almost exactly what I need just out of this piece. Okay, so let's cut this one directly in half. 24. Yeah, and that would be... Okay. Because I need these all to be similar, I'm just going to hit them on the table saw. Because I've got some width disparities here. Table saw will take care of that forthwith. Yep. Okay. So that goes. And that goes. That's it. 1, 3. Using the ruler as my template here, I am guaranteeing that all these are exactly the same width, which I need them to be, because I'm effectively making some little I-beam sleds to anchor this, this garbage can. The anchor is just going to use a pair of feet made of Velcro to hold on to Spot. But because the whole garbage can itself is super lightweight and weighs ounces, it shouldn't have any difficulty, and it's not going to throw off his weight at all. Almost. Let's cut 4 of these. Oh, let's cut 8 of these down. Will that work? Yeah, I think that actually might work. Okay. So here's what we're gonna do. We're gonna double up 2 of these. And we're gonna make an I-beam. Look at that, right? I love working with this stuff. Yeah. Okay, so there's one, and we'll get going on the other. Painting in the gussets. Yep. Yeah, just want to get into all the small spaces where glue might not have gotten. Excellent. Excellent. One of them's, I did one of them upside down, but it doesn't matter. That's totally fine. Okay, now, right, I need to adjust a little bit. There. We're going to make a little bandsaw cut. Now, oh, right, the distance between the Velcros. The distance between is 5 inches outside to outside. Okay, so yeah, there we go. That's actually going to work out just perfectly. I'm going to get some glue on the styrene to weaken it up, soften it up, get it to want to accept this bond. It's an arranged marriage. That's it. Yep. That's good. Get some more in there. The glue is thin enough that it actually wicks in where you want to put it. Oh. Okay, and the other one, same smell. Soften you up for the kill. Add some glue to grease the wheels. Sock it in. Of course, I'm making the assumption that my bottom is flat. The assumption could have boned me, but it's going to be flat enough. Oh, yep. So now I'm, starting to delaminate there because I added a little too much glue. So let's add in some strength, just so it doesn't get away from me. Just adding some more surface area to grab and secure in the corners, just to make it a little more robust. I'm trying to do a lot in a short space of time, but it's still working. Look at that. That's, what are we, half an hour in? Half an hour in to a cantilevered offset garbage can for my robot dog's butt? Okay, so let's get some Velcro on there. All right, moment of truth. Here we go, Spot. Oh. He looks great. Yeah, we had to aestheticize it to work with Spot's color scheme. All right, Spot. Yeah, I guess it's time to turn him on and let's walk him over to do some trash pickup. All right, well, if Spot's gonna pick up the trash, he needs some trash, so we've got some. And we've got everything from, like, you know, pieces of crumpled up paper to, oh yeah, this shifting load. It's difficult for my friend Ken Goldberg's part picking robots at Cal. That should provide an interesting challenge. We've got I'm not even sure he can grab this one. 3D printed. Oh, tape measure. Yep, okay, we got that. I wonder if he can pick up his own shoes. My kids never could. And other Borscht Belt jokes. All right. It's a mess in here. I wish someone would clean it up. Grasp wizard. Ooh. Let's try it. I think that's a good angle. Come on. Oh, okay. Yep. There we go. Come on, buddy. Come on, you can do it. There we go. Okay. Close gripper. Oh, hey! Continue, grasp, succeed. Oh, yes. There we go. Oh, come on. Come on. Come on, baby. Come on. You can do it. I was so like not ready to celebrate because I thought it would just like fall off his back, but that was the most difficult, I think, of the objects we have. Well, I mean, shifting load. It's not the most difficult of the objects we have. I get it, but that was cool. All right. Reset. Isn't that awesome? Clears his trash receptacle. Let's go again. Let's see what else we can grab. Okay, let's just try this piece of paper here. Grasp wizard. Let's look at that piece of paper. You didn't see that. You saw nothing? All right, here we go. Next, coming in. A little farther. Yep. A little farther. Come on. Come on. All right. Close gripper. Oh! Grasp succeeded. Ladies and gentlemen, I'm still learning the controls. Come on. There we go. That's it. Let's see if that works. Oh, 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 oh. Oh! Yep, there we go. Now you're in. Okay, next. Go get it. Go get it, Tiger. Go get it. It's all yours. Okay, down, down, down. Excellent. Come on in, buddy. You can do it. Little more. Little more. You're so close. You're doing great. Close that gripper. Yes! You got it. Okay, raise it up. Hold on. All right. Turn it around. Let's get it. Hey! Reset! Yeah! All right. Now we're gonna go for one of his shoes. That one right there. Yep. Okay, Grass Wizard. Let's see if you can see the shoe. I can. Go get that shoe, buddy. Go clean that shoe up. Next, come on in. A little more. Oh. Did you get it? Hey, we did it! Oh, it bounced off the water. It's not my fault. It's not my fault. Hey! That is great. Okay, we're gonna try the Stormtrooper helmet. I don't know if this is gonna work, but we will see. Yep. All right, let's goose it north. Yep. And to the left slightly. Oh, no. And a little farther down and close the gripper. Oh, successful? Maybe? Oh! I didn't even dream that it was possible. All right, throw that puppy away. We got to clean our whole room. Ladies and gentlemen, everything I'm doing now is with Spot's manual controls, meaning I am directly controlling all of the motions the arm makes. But Boston Dynamics has included automated behaviors to make a lot of these actions easier and faster. They also made it possible to completely program the arm. So for instance, I could create a put away the trash program that would automatically drop each piece of trash into the pail once it's picked up. And we will explore that more soon once we get to know Spot's arm a bit better. I want to pick up some more trash. All right, buddy, let's see here. What do we got? We got a couple more pieces of, oh, we have a tape measure. That tape measure. All right, we're gonna try the tape measure, but I'm gonna do a piece of trash just to get my momentum up. Nobody's gonna get that piece of paper but you, buddy. It's all yours. You can have it. It's all yours. Close the gripper. Oh, did we get it? Was it a successful grasp? Come on. Oh, we did! I am getting good at this.
This is the pride that goeth before a fall.
Oh, there we go.
Okay, now the tape measure. I don't have high hopes for the tape measure. All right, I'm gonna walk you through the steps that the grasp wizard uses to execute a grasp. And understand that each of these, while these are steps that I choose, these are easily put into a AI algorithmic flowchart for Spot to determine what and how he can pick it up. All right, so I press grasp wizard. There we go. And the first thing that I'm confronted with is a view of his front camera. So I point to the thing that he's gonna grab, and that's the tape measure. And I point to it, and now he addresses the tape measure. And I can choose how he is going to attack it. Right now, oh, hi, Maggie. This is our live dog, just for control testing. Hi, sweetness. You gotta go over there. I know, I love you. Go. So I can choose the attitude with which Spot grabs this, not the attitude, but like the angle at which he approaches it. And for the tape measure in its current orientation, I think I'd rather be at a 90-degree straight above angle. So I choose that. Then I click next, and now I can move his jaw closer to the target. And I have a feedback on the screen as to how I'm doing. I can also jog for micro positional increments just to make sure I am where I want to be. Yeah, I feel good. I'm gonna close the gripper. Oh, reset, grasp failed. And now he comes in. We're trying 60-degree angle this time. Let's do there. Come on. That's it. Successful grip. Okay, so. Okay, buddy, come on. Let's get it in there. All the way around, all the way around, all the way around. Oh! Good job, little buddy. I know that what we've been doing here this morning seems patently absurd. A highly expensive and refined piece of robotic equipment used to pick up little pieces of trash. But there is actually a wisdom to the play. And it's one that I first came across when I was learning how to juggle. When I first was understanding how important practice was to juggling, I started I would have these tricks that I couldn't get. I would practice a certain maneuver and I couldn't get it all day. I'd be practicing. I couldn't get it. I'd go to sleep, wake up the next day, try it again, and it would be right there in my hands waiting for me. Like the skill had fermented overnight in my head. And all the iteration I had done the day before, even though it felt unsuccessful, was actually telling my body important things. And the same is true for Spot here. We think of him as an individual, but really he's a platform. And as a platform, it's really vital that every single one of us with Spot runs him through as many different paces as we can imagine. And each of these ends up being the iterative skill base that will ultimately create a Spot that can do things we never imagined. But the play is really important and a vital part of that. It's why lion cubs and wolf cubs and orcas all play. Same thing for Spot. The play is a vital way in which he gets to understand the world, and we understand the world that he sees. Look, the release of this arm is focused right now much more on developers than end users. But Boston Dynamics API allows innovators and developers to build applications on top of the skills that Spot can perform. So while what we did in this video was a lot of manual control of exploring each individual skill, the next step that I'm really excited about is rolling up our sleeves and building some more complex behavior on top of that library. Thank you for watching that entire video. If you'd like to support us further, you can head over to the Tested store. Links are in the comments below, and you can buy things like our demerit badges. You've heard of merit badges. These are the opposite. This one here is for measuring once and cutting twice. we went back and forth whether to measure once and curse twice, because that also happens. We went with the cut twice. And this is one of my all-time favorites. This is when you accidentally release the mysterious blue smoke that makes all electronics work, and then they no longer work. You can't release that smoke. Head over to our store, get yourself some demerit badges, and we will see you next time.